Hey friends, it's Mr. Pouts, and we're going to do lesson 4.2, which is all about patterns and linear functions. Now, if you remember from last section, the first section in chapter 4, we dealt with graphs and how to look at graphs and figure out things about graphs, and then how to make graphs based off of situations. We're going to continue with some things with graphs, but our goal right today is focusing on a couple things. So write down the goal, please. I can identify and represent patterns that describe linear functions. So we're going to deal with linear functions or linear graphs, and we're going to talk about them in words, in tables, and also in equations. So a couple vocab words, actually a few. I know for sure you might want to look at your vocab list. Two or three of these I think are on the vocab list for the chapter. First one is dependent variable, and you might remember back from last chapter, or sorry, last year, that a dependent variable is a variable that provides the output of a function. It's a value, or its value depends on another variable. So usually when we're dealing with equations, our dependent variable is the y. So if we have y equals 6x plus 2, you can see that there's two variables in there, things that would change. That would be the x and the y. The dependent is going to be that y, because it depends, y depends on whatever x is going to be. So that means that the independent variable is the x value, and the independent variable is the variable that you can change. You can plug in different things for x, and you'll get a different y out. It also provides it provides the input values of a function. So I'm going to actually slide down here and say, what is a function? We kind of talked about a function, but whoa, that was crazy. A function is a relationship that pairs each input value with exactly one output value. So if you think of a machine, let's say you have a slot machine, and this is going to look really bad, I'm sure. Let's say you have this slot machine. You're playing this game, and you have to get, like the three things in a row. You have the things here. I know you're not allowed to gamble yet. You have this big crank over on the side. You grab that thing and you pull down it, but you have to put something in there for it to work. The input value is where you input coins into your machine, and your output could be whatever you get in return. You might get something in return here, some money in return if you win. So the input value of a function um, is the values of the independent variable. Those are the ones that you get to choose, or it would be your input values. The output is the dependent variable, which would be what you would get out of it. So the output then would be if you were to get something out, like a whole bunch of money if you win the lottery. But that's my, don't tell Mrs. Bergman that that's my picture, but that is my slot machine, or my game where you can put coins in. Alright, and the last one is a linear function. A linear function is a function, when we're talking about input and output values, whose graph is a non-vertical line. So it's a line. You can see, hopefully you could tell in the word linear is that word line. So when you're graphing something, you have a line going across. That's a linear function because it's a line on the graph, as long as it's not vertical. Vertical lines are not functions. All right, let's get to the meat and potatoes of this stuff right here. So first thing is representing a geometric relationship. So oftentimes, let's read this through. Oftentimes the value of one variable, the dependent variable, is determined by the value of the other variable, which would be the independent variable. These relationships can be represented many different ways, including graph or tables, equations, graphs, or in words. So we're going to do that now. Here's the situation. Problem 1 says, in the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? So remember, perimeter is your outside, how much is on the outside that goes around the perimeter of it. So let's represent this using table, words, equation, and graph. So we're going to do all four of those. So if you look at it, well, this side would be 6 as well, and this side would be 1. So that's one rectangle, and the perimeter looks to be 12, 13, 14. Two rectangles, if this is still 6 and this is 1 and this is 1, Looks like we just added 2 to it because we still have 12, and then we have 13, 14, or 15, 16. Same thing with the next one. We're adding 2 more to it because we're adding just those one sides. So let's make a table to represent this, and I'll show you a couple different ways. But if you look at it, it seems like you always have the sides that are 6 and 6. So we're always going to be adding that 12 to it. So let's make our x value our, the thing that's changing is the number of rectangles. That's going to be our x value. Our y value can be the perimeter. So there's our t-chart. We're going to be using lots of t-charts, or these are also called tables. So use x as the independent variable, y as the dependent variable, and we have right there, right? Each pair of input as a, all right, we'll do the ordered pair over here as well then at the end. That says ordered pair. Trust me. All right, so if we have the number of rectangles, if the number of rectangles is 0, well, obviously the perimeter is 0. But let's say we have 1. We know we have to do 1. We have to add 12, so we have 12 added to whatever it is. But it's just, well, if we look at here, it's 2 times the number of rectangles. So we'd have 2 times x. Or in this case, 2 times 1. We have 1 rectangle, that's going to be, the 2 comes from right here. 1 and 1 would be 2. And that'll equal a total of 2 times 1 is 2 plus that's 14. So the ordered pair would be 1 and 14. Now, let's say that we have 2 rectangles. That's shown right there. 2 rectangles, we do 2 times 2, because we have 2 rectangles now, plus that 12 that's always going to be on the right and left sides. That'll get us 16, because 2 times 2 is 4. With 3 rectangles, we still have that plus 12 there. Whoops. But we're going to do 2 of those sides times 3, because we have 3 rectangles, so 2 times 3. 2 times 3 is 6, plus 12 is 18. So I'm not writing these ordered pairs in here. So it'll be 1, 16. So it'll be 1, 18. And don't forget the parentheses when we're dealing with ordered pairs. And not 1, I mean 2 and 16, and 3 and 18. Let's do one more. Let's do 4. So 2 times 4 plus the outsides are always going to be adding up to 12 is equal to 8 plus 12, which is 20. So the ordered pair would be 4, 20. So if you look at this, we have a whole bunch of x values, a whole bunch of y values, and then we put them into ordered pairs. So we're just looking at the patterns here. Sometimes it's easier to find the patterns than other times. Now, if we're putting it into words, it says, look for the pattern in the table, describe the pattern in words so you can write an equation to represent the relationship. So in words, we're multiplying the number of rectangles in each figure by 2 to get the total top length and the bottom length. So that's what we did. The total top and bottom is just 2 times however many rectangles there are. And then it says, then we add 2 times 6, which we said is 12, because it's always 12 on the outsides. There's the 2 6s. And for the total length of the left and right sides, and combined we get you the entire perimeter. So that's kind of putting it into words. That was a lot of words for that. But then if you put it into an equation, they got y equals 2x plus 12. How do they get that? So if you look at it, our y values are always determined, that's going to be by itself, that's the dependent variable. It's always determined by 2 times the number of rectangles, we said, times the number of rectangles, plus that extra 12 that are going to be on the sides. And that's where this equation comes from. Okay, a lot of times we will see equations in this form, y equals something times x plus something, or minus something. All right, then if we were to represent it in a graph, you have to make a graph. with an x and y axis, which we talked about last time, x always goes with the independent variables and y always goes with the dependent variables. And then if you graph it, I know this isn't, it looks like the left side they went going up by 4s, because this would be 4, 8, 12, 16, 20, and 24. Um, the first ordered pair we had was 1 and 14. So that's right there, 1 and 14. Then it was 2, 16, 3, 18, and 4, 20. And that's the graph. So we represented them 4 different ways: the table, the equation, the words, and the graph. And usually, if you can make a table, that helps so much, because that can tell, it shows you patterns, and it helps you figure out a lot of stuff with the table. So what I'd like you to do, actually here I have one more tip for, and this will make it easier for creating an equation, hopefully. So look at successive differences in the x and y values. So if we looked at our x and y value, we had the x value, I'll take it down here, we had 1, 14, 2, 16, 3, 18, and so on like that. Successive differences in x and y values means as the x goes up by however many, this is going up by plus 1. How many are the y changing by? Plus 2. Plus 2. It's the same thing every time. We can take those successive differences then and put them in the change of y over the change in x. So that change of y over change in x would be the change in the y's is plus 2. Change in x would be positive 1. So that's that fraction, which is a change in y over change in x. That common fraction then we can put into the equation y equals fraction, that fraction times x. So y equals 2 over 1, or 2 over 1, or 2 times x. And then we can plug in an x value. It says check to see if you're multiplying by a fraction by each x value will give you the correct y value. So we do that. Let's try that with 14. Let's do y equals 2 times 14. Sorry, 2 times 1. We're following in the x value. So y equals 2 when x is 1, but that was 12 off of what it's supposed to be. It's supposed to be 14. So that says if it works, your equation is done. But if it doesn't, like we said here, find what the difference is and add that to the end. So we take our y equals 2x. Oops. So it's going crazy. Y equals 2x, and add the 12 to the end. All right? So that is a shortened way to write an equation. So what I'd like you to do with this is to take this and try this on your own. It says in the diagram below, what is the relationship between the number of triangles and the perimeter? Represent this relationship using a table, words, equation, and graph. So I'll start you off with the table. If you look at the table, and again, this is with one triangle. I think the perimeter of our x, which is going to be the number of triangles. The y, which will be the perimeter, we'll leave it at that. You can make it into ordered pairs if you'd like. Whoops. So the x's would be, so if we have one triangle, what is the perimeter? 3 plus 3 is 6, plus 4 is 10. Okay, what if we have two triangles? Now this middle side, this side right here is actually gone because it's covered up. So we just have 3 plus 4 plus 3 plus 4, which would be 7 plus 7, which is 14. So it goes up by 4. Now we have three triangles, and I'm going to let you finish that. Now make sure you then put those points into a graph. You explain it into words, and then you try to make an equation from it. All right, you can actually skip B and C for right now. So do that on your own, please. All right, let's go on to the last part, representing a linear function. So we're going to look at a table, and we're going to represent a linear function and come up with an equation, maybe even using those shortcuts that we said. But let's just read this situation first. It says, the table shows the relationship between the number of photos you take, so that's the x, and the amount of memory and megabytes left on your camera's memory chip. I don't know if you've ever noticed, phones do that too. The more things you put on there, the more pictures and stuff, the less memory you have left to use. Kind of like when you use your data. The more data you use, the less you have left. Um, or the more apps you use, the less data you have. Um, but is the relationship a linear function? We want to know if it's a linear. So if it makes a line when you graph it, describe the relationship using words, an equation, and a graph. So let's look at those successive differences first. I mean, maybe I did this down here. Let's see. Well, let's see. I think I might have. If we look here, let's read right here. It says the amount of y of memory left is uniquely determined by the number of photos you take. So that's exactly correct. You can see this in the table above where each input value of x corresponds to exactly one output value. So it's a function. To describe the relationship, let's look at how it changes. So actually, let's just go back. Every time you add another photo, looks like the memory goes down. And that makes sense. The more photos, the less memory you have. So if we look at those successive differences that we talked about, as you go up, as you add one photo, you actually go down in memory. So we said to use that fraction that of change in y over change in x, which would be -3 over +1, which is actually the same thing as -3, if you'd like to leave it at that. -3 divided by 1 is -3. In words, it was described like this. The amount of memory left in the chip is 512, because you start at 512, minus 3 times however many photos taken. So the equation I'm going to take is, like we said before, let's start with y equals, and we have that -3, that y over change in y over change in x times x. Now, you could plug a value in and see that it's not going to be this. This isn't your exact equation, because if you plug in 0, you'd end up with a 0 or a y equals 0, but the y should be 512. So this is a shortcut to actually plugging things in and figuring out the difference. You can look wherever the x is 0, and whatever that y value is what you'd add to the end of your equation. Okay? So you'll get used to that, hopefully. Figure out the successive differences, the change in y over the change in x. Put that in front of the x in your equation, and then add this value, whatever x is 0, add the y value to it. So that's your equation. And in a graph, you just plot the points, and if you look at it, it is going to be a line. It's linear. All right? So we're going to actually try this one in class next time together. So if you want to try it on your own now, you can. We're looking for words, an equation, and a graph for this function. We want to figure out if it's linear as well. All right, that is all. Make sure you have that goal written down. Hopefully you learned something. We'll see you next time.